So in this video we'll be looking at anti-differentiation or integration, in other words. And just on the right here I've got this general rule which is f dash of x is equal to a and x, which is a gradient function. Right, and once we anti-differentiate or integrate, we'll get f of x is equal to ax to the power of n plus 1 over n plus 1 plus c. Okay, so the idea with anti-differentiation or integration is just the opposite to differentiating. We're going from the gradient function to the original function, right, or to the actual curve, okay, and you just go through the opposite steps of differentiation. And that's the key idea, really. The plus c is just a constant. Okay, we always add a constant. So if you think about differentiating maybe x squared minus 5, you get 2x. And if you differentiate x squared, you get 2x. So that's how when we go back in reverse, we must add that constant to satisfy to say, oh, well, there could be a constant term there, but we'll have to find that out later on. So let's look at anti-differentiating something. So let's just say we had a function, f dash of x is equal to 3x squared. A general function, 3x squared, and we're going to anti-differentiate this. So we use this little symbol, okay, the little elongated s, which is called the integral. Okay, and we put our function in between, and we put dx. Okay, so what that pretty much means is, well, this over here is our integral, and that is just saying what we are integrating in terms of. So this sentence is like a sentence saying we are integrating 3x squared with respect to x. Okay, so it's a sentence. So you're just telling the person that's probably reading this saying, oh, this is what I'm actually going to do. I'm going to integrate this function with respect to x. All right, so now we go through our process of integration. So we'll have 3x to the power of 3, so 2 plus 1, divided by that new power, plus c. All right, so this now becomes f of x. All right, we can obviously simplify that, and we get, well, f of x is equal to 3 over 3 is just 1, so x cubed plus c. All right, and that constant could be anything, right? But we just leave it as plus c. That's how you actually leave your solution. All right, so let's look at anti-differentiating another function. So let's say we were given a function. Scroll up a bit more. F of x is equal to 4x to the power of 3 plus, we'll go 6x to the power of 2 minus 7x plus 5. Okay, just a general function. Oh, that should be f dash of x actually, sorry. And we're going to integrate this. So we put our elongated s over there, so we put our function 4x cubed plus 6x squared minus 7x plus 5 and our dx. So again, we're saying we're integrating this function with respect to x. Okay, so now we get f of x, the original function, and we get 4x to the power of 3 plus 1, which is 4, and we divide by that new power, plus 6x to the power of 3, and we divide by that new power, minus 7x squared, and we divide by the new power, plus 5. Since 5 on its own, we add an x to it. And we have our plus c. Cool. And now we just go on and simplify this function. So we get f of x is equal to, well, 4 over 4 is just 1, so x to the power of 4 plus 6 over 3 becomes 2, so 2x cubed minus 7 over 2 x squared plus 5x plus c. All right, and that is how you anti-differentiate or integrate polynomials.